We have seen that the same expression can be written in different but equivalent forms. Let's rewrite the following expression so that it is in simplest form. Show using algebra tiles. 2x plus 3x. Now this might seem mundane to us, but for someone just starting out, showing that they are the same is important. So if we have 2x and we add 3 more x, I see that all together I have 1, 2, 3, 4, 5 x's. So this is equal to 5x. Like terms are terms that contain the same variable and exponent, just like 2x and 3x, y and 2y, 4 and 6. Non-like terms would be something like 2x and y. If we look at 2x and we bring out y, these are not the same, so we cannot combine them together. Rewrite the following expressions so that it is in simplest form. Show using algebra tiles. Okay, so our first one is negative 3x. So I'm going to put up negative 3x here. And then it's plus 2. So plus 2. Okay. Minus 4x. So 1, 2, 3. We need another one. 4. And minus 6. 1, 2. We'll just put them next to here. 1, 2, 3, 4, 5, and 6. Okay, so we can combine all of these together to give us a total of 1, 2, 3, 4, 5, 6, negative 7x. I see that I've created two different groups of 0, so then I just need to bring down negative 4. So our final answer for this one is negative 7x minus 6. Okay, so our next one is 3x. So we're just going to start over. 3x minus 2 plus 1 minus 5x. 4, we need another negative x. Minus 5x minus 7. 1, 2, 3, 4, 5, 6, 7. Plus x, so plus a regular x. So I see that I'm going to be able to cancel out some and make zeros of x's. So I'm just going to do that now to get rid of them, pair them off here. I see I have one group, oops, and I have another one over here. So these pair off. So it looks like all we have left is negative 1x minus 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to negative 1x minus 8, or negative x minus 8. Now this next one here, negative 2x plus 1 and 5/10 y minus 4x minus 6 minus 4y plus x plus 10 and 5/10 x, or 10 and 5/10. We have some decimals, and that's kind of where the algebra tiles start failing us. We don't have decimal forms of them. So at this point, after you've done many different examples with whole numbers, students should be able to see that we can group some of the common terms together, such as negative 2x minus 4x plus x. So negative 2 minus 4 will give us negative 6, plus 1 should give us negative 5x. Then let's look at our y's. I have 1 and 5/10 y minus 4y gives us a positive, or a plus a negative 2 and 5/10 y. And then finally, we can combine our whole number pieces or our numbers that are by themselves. So negative 6 plus 10 and 5/10 gives us a positive 4.5, or 4 and 5/10. Simplify the following expression by combining like terms. So here we notice that the 7 is on the outside, so we need to distribute that 7 first. So I'm going to distribute 7 to the negative 1/10 and x and to the 5/10 y, as you can see, which then means I can multiply my numbers together, giving me negative 7/10 x plus 3 and 5/10 y, and I just kind of tack on the remaining. I then see that I've got some x's together that we can combine together. So negative 7/10 x plus 1x gives us 3/10 x. And when we look at our y's, I have 3 and 5/10 y minus 5/10 y gives me a positive 3y. Ashley asked her friend Abby a riddle. Abby decided to use a tape diagram to solve this, and she decides that Ashley's number is 5. What might her diagram look like? How can we check her answer? If I take a number, multiply it by 3, and add 2, then the result is 17. So using a tape diagram is another way versus algebra tiles, but equally as effective, especially since it can work with decimals and fractions. So here's a number. It says if I take a number, multiply it by 3, so 3 n's, and then add 2, this result altogether is 17. So our equation is 3n plus 2 is 17. If I plug in 5, because Ashley says the number is 5, we get 15 plus 2 equals 17. Jason wants to buy a video game console and 2 games that are the same price. The store is selling the bundle with 2 games and the console for $170. The game console by itself costs $120. Represent the situation with an equation where G is the price of one video game. How much does each game cost by itself? So again, it wouldn't be logical to use algebra tiles because 120 and 170 is fairly large. So we know that a game console plus 2 video games altogether is $170. We also know that the game console is $120 plus the 2 video games, which we represent with G, must equal 170. So I have the tape diagram here. So I have 2G plus 120, all of it together must be $170. Well, I see if I cut a line down and put the variables on one side and the numbers on the other, if I were to subtract 120 from both sides, that kind of knocks it off and I can just look at a portion of the tape diagram. So algebraically, I have 120 plus 2G minus 120 equals 170 minus 120. So 2G is equal to 50. Well, I can split that right down the middle. So if I were to divide it in half, each game, therefore, must be $25. And if we plug it back into the original equation that we discovered, 120 plus 2 times 25 certainly is 170. So a solution to an equation can be found by creating a series of equivalent equations using the same operation on both sides. So notice when we were figuring this out, we subtracted 120 from both sides, and when we were about ready to get G by itself, right here, we divided both sides by 2. Solve the following in 3 ways. 2n minus 5 is 23. So let's use the tape diagram first. 2n equals, must be something minus 5, so 23 minus 5. Well, what we can do then is add 5 to both sides so that n equals 28. Dividing it down the middle, n equals 14. Let's use operations on both sides algebraically. So we add 5 to both sides, so 2n equals 28. Divide each side by 2, n equals 14. So let's use algebra tiles. All right, so I've kind of got it set up for us here. For my background, I chose the equation mat, completely your choice if you want to use it or not. I just thought it'd help us kind of keep things separate. So I have 2n or 2x minus 5 equals 23 over here. So what I need to do now is get our x's here by itself. So to do that, I need to add in a series of zeros here, right? So 1, 2, 3, 4, 5. And what we do to one side, we have to balance out the other side. 1, 2, 3, 4, and 5. So now I've created a bunch of zeros. So all of these now get to disappear. Okay, and now I'm left with, and I'm just going to turn them on their sides, I'm left with 2x equals 28. So if I were to split these up, there would be 14 that belong to this x and 14 which belong to this x. So x equals 14.
Solve for the value of x by using the same operation on both sides. So another reason why I also like using these strips here is because we can show fractions more easily. Algebra tiles are great, again, with whole numbers, but not so great when we have fractions or decimals. So we have 1/3 of an x plus 7 is 10. So notice that this part here represents 1/3 of the whole value of x, which is why it's only shaded 1/3 of it. But then this whole piece must be 10. Then what we can do is subtract 7 from both sides. So if we were to take this bar here and split it down and subtract 7 from both pieces, we end up with 1/3 of x is 3 equals 3. Okay, so then if we know that this part is 3, then each one of the remaining ones also must be 3. So therefore, 3 times 1/3 of an x equals 3 times 3, which is 9. Solve for the value of x by using the same operation on both sides. So when I look at negative 1/2 x plus 4 copies of 1/5 equals negative 5 copies of 1/6, I can look at my denominators and see that 30 is the common denominator. So we're going to be efficient and solve the equation using the least common denominator amongst all of our fractions. So I will multiply everything by 30, which gives me negative 30/2 x plus 1/25 equals negative 156. And you can notice that each one of those can evenly be divided, giving me negative 15x plus 24 is equal to negative 25. So now we have to use the same operation. So we need to get that x by itself. So first we're going to subtract 24 from both sides, giving me negative 15x equal to negative 49. We then need to divide both sides by negative 15. So x is equal to 49/15. Is there a best way to illustrate why 3 times 5 plus 2 is equal to 3 times 5 plus 3 times 2? Well, on the left-hand side, looks like this particular student just wrote 5 plus 2 3 times. And then they rearranged them to be 5 plus 5 plus 5 plus 2 plus 2 plus 2, which is the same as 3 copies of 5 plus 3 copies of 2. Whereas this student did 3 by 5 plus 2 and broke it down. We have 3 copies. We can keep on breaking them individually. So we have 15 plus 6.